So let's try the 55th question now. So the limit as n approaches infinity of this sum as r goes from 1 to n of r upon 1 into 3 into 5 all the way till 2r plus 1 is equal to. So till 2r plus 1, that means that there are r plus 1 terms on the denominator every time. So for r equals to 1, this will be like 1 upon 1 into 3. Then you have 2 upon 1 into 3 into 5 plus what do you have 3 upon 1 into 3 into 5 into 7 and so on. So what I can do is that I can multiply by half and 2, and that will give me 2 upon 1 into 3 plus, let us see, 4 upon 1 into 3 into 5 plus 6 upon 1 into 3 into 5 into 7 and so on. Okay, cool. So what now? Just like a previous video in which I did a similar kind of question, what we are going to do is that we're going to notice that 3 and 4 have a difference of 1, then you have 5 and 6 which have a difference of 1 and so on. So that will be like 1 by 2, and then I will multiply by 1 everywhere, and this is a special one because I will write this 1 as 4 minus 3 first of all. So that will give me 4 into 2 upon 1 into 3 minus 2 upon 1. Then for this one I will write it as 6 minus 5, so that will be like 4 into 6 upon 1 into 3 into 5 minus 4 into uh, 2, wait a second, um, it will be like 4 upon 1 into 3 into 5. So that's not working, is it? Okay, so 3 to 4 you got a difference of 1, similarly everywhere else. Right, what can we do over there is that we can write that thing like this. Yeah, okay, cool. So that should be working, no problem. I can write 1 as 4 minus 3, so that's like 4 into 2 and stuff, and then this can be written as 6 minus 5. So okay, that 5 will cancel with that thing, so 4 upon 1 into 3. Doesn't look nice to me. Yes, it doesn't. What is going wrong over there? So 6, that's getting added over there, but and then similarly 5 is getting removed over there. Yeah, it's the same thing, and then 4 was added, right? So it should have been something like 4 into, this is here, it's like 4 upon 1 into 3. Not sure where we are going with this. Okay, that's not the way to go around this. Okay, so first of all, let's try to manipulate this to get a solvable series, maybe. So I can write this 2 as 3 minus 1, maybe. I just remove these ones, these extra ones. So it's like 2 upon 1 into 3, then 4 upon 1 into 3 into 5, and so on. So I can write this 2 as 3 minus 1, so that will give me 1 upon 1 minus 1 upon 1 into 3. Then similarly I can write 4 as 5 minus 1 over there, so that will be like 1 upon, okay, so in fact it's a much easier series. Okay, so this series telescopes very easily. It's not like the one which we did previously. Okay, fine. So 1 upon 1 into 3 minus, so you have minus 1 upon 1 into 3 into 5. Then for this guy, this will be 1 upon 1 into 3 into 5 minus 1 upon 1 into 3 into 5 into 7. Just writing 6 as 7 minus 1. So yeah, you can already see the pattern that this cancels with that, this cancels with that. In fact, all of these terms will get cancelled except the last term, which will be minus 1 upon infinity, but that's 0, so never mind that. So the answer is half. Okay, cool. So let's move on. Okay, so the next question is Consider an infinite geometric series with the first term a and common ratio r. If the sum is 4 and the second term is 3 by 4, then okay, cool. So the sum, which is a upon 1 minus r, is 4 and the second term is 3 by 4, so ar is 3 by 4. Then we just need to find the values of a and r in this case. So let's just divide by that thing. So that will give me r into 1 minus r. That has to be 3 by 4 divided by 4 once again, so like 3 by 16, something like that. 3 by 16 looks correct. Okay, cool. So that gives me r minus r squared is equal to, in fact, 16. So 16r minus 16r squared is equals to 3. So 16r squared minus 16r plus 3 is equals to 0. Let us see if we can factorize this. So 16 into 3, that can be written as 4 into 12. Yes, that can be factorized. So 16r squared minus 12r minus 4r plus 3 equals to 0. So that gives me 4r into, let us see, 4r minus 3 minus of 4r minus 3 is equals to 0. So r can be 3 by 4 or r can be 1 by 4 in that case. Okay, fine. Yeah, it looks correct, no problem, right? Yep, so r can be 1 by 4 or 3 by 4, and the first term, where is it? Okay, with the first term a and common ratio r, the sum is 4, the second term is 3 by 4. Okay, so what will that give me? So you have these two values, r equals to 3 by 4 or r equals to 1 by 4. So suppose r equals to 3 by 4, then a has to be 1. If r equals to 1 by 4, then a has to be 3. Let's just check if this equation works out. So 1 upon 1 minus 3 by 4, that has to be 4. Okay, that's correct. And 3 upon 1 minus 1 by 4, that is also 4. So that's also correct. So r equals to 3 by 4 and a equals to 1, that could be a possibility. But it's not over there. So the next one, which is a equals to 3 and r equals to 1 by 4, that will be our answer. Okay, so let's move on. An infinite, oh, we moved a little too much. Fine. So what do you have? Let's erase some stuff. So the next question is, if Tn denotes the nth term of the series 2 plus 3 plus 6 plus 11 plus 18 all the way till what? Okay, the nth term of, wait, what? Okay, so till n terms, fine. Then T50 is, okay, so the series is 2, 3, 6, 11, 18. Right, so the difference is 1, then the difference is 3, then the difference is 5, then the difference is 7, and so on. So these are like odd numbers, so the difference is always an odd number. Let us see. So the series is 2, 3, 6, 11, 18, and so on. So the difference is, first of all, just 1, then the difference is 3, then it is 5, then it is 7, and so on. So in that case, I can write 3 as 2 plus 1. I can write 6 as 2 plus 1 plus 3. I can write 11 as 2 plus 1 plus 3 plus 5. I can write 18 as 2 plus 1 plus 3 plus 5 plus 7. Okay, cool. So in general, if I have, let's see, so 1 2 3 4 fifth, for the fifth term you had 2 plus the first 4 odd numbers. So what I can say is that in general, if I have the nth term, instead I will just use tn over there. So if I have the nth term, then that's supposed to be equal to 2 plus the sum of the first n minus 1 odd numbers, but we know that that's actually just n minus 1 squared. Okay, cool. So that has to be equal to n squared minus 2n plus 3, something like that. Fine. So what we want to find? We want to find T50. Okay, so our T50, that will turn out to be 50 squared. We'll just erase some stuff first of all. So our T50 will be so I will put n equals to 50 over there, so it's 25 hundreds minus 100 plus 3, which is 2400 plus 3, which is 2403. Yes. uh oh, so they put it differently. So okay, 2 plus 49 squared, right? This would be the answer. Fine, so let's move on. The coefficient of x power 49 in the product, x minus 1 into x minus 3 all the way till x minus 99 is. Okay, fine. So x power 49. Oh, uh, how many terms are there in this? How many factors are there in this product? So 1, 3 all the way till 99. The difference is 2. So 99 minus 1, that's supposed to be 98 upon 2. So upon 2, that will give me let us see, 98 upon 2, that has to be 4, then 18, so 9. So there are 49 jumps, but an extra term in the first, right? So 1, that's supposed to be the first term. So 50 terms in total. So the degree of this polynomial will be 50, and the first coefficient, which is the coefficient of x power 50, that will be 1. So that means that the coefficient of x power 49 will be the sum of the roots of this polynomial, but we know that the roots are just 1, 3, so on till 99. Okay, so our coefficient of x power 49 will turn out to be 1 plus 3 plus so on. In fact, actually the negative of that thing. Okay, so 1 plus 3 plus 5 plus 7 all the way till 99. So how many terms are there? There are 50 terms in this thing, so it has to be like negative of 50 squared. Okay, that looks correct. Yes, so negative 2500, that should be nice. Okay, so the next question is, if a, b, c are in ap and b minus a, c minus b and a are in gp, then a is to b is to c is. So first of all, 2b equals to a plus c, and these are in gp. That means that the square of this thing, which is c squared minus 2bc plus b squared, that has to be equal to the product of the other two, which is ab minus a squared, right? So what now? Now we just want to substitute the value of b as a plus c upon 2, or in fact just multiply this equation by 2. So that will give me c squared plus a squared plus b squared. Okay, so you want to multiply this by 2. Instead, let's multiply by 4 over there. So that will give me 4c squared plus 4a squared. Okay, minus, okay, so plus 2b complete squared is equal to 8bc plus ab. Over here you will have 4ab, in fact, plus 4ab. Okay, so that gives me 4c squared plus 4a squared plus, what is 2b? It's just a plus c complete squared. That has to be equal to, first of all, let's see, you have a 4b common. Okay, cool. So I'll let us 2 into 2b, and then the remaining stuff is, what's the remaining stuff? Right, so you have 2c plus a over there, and then this 2b can be written as a plus c. Okay, cool. So now we have a quadratic in two variables, in fact a homogeneous quadratic in two variables. So let's just deal with this. So that will give me 4c squared. Okay, fine. So 4c squared plus 4a squared plus a squared plus c squared plus 2ac. Sorry for that. That has to be equal to, let us see, so 2 into a squared plus, what can we do, 3 ac plus 2c squared. Okay, which is nothing but 2a squared plus 6 times ac plus 4c squared. So this cancels with that thing. Got 2a squared over there, so that is gone. Just got 2a squared, right? So let's see what we get. So it gives me 2a squared wait, in fact 3a squared, because that is also over there, plus c squared is equal to 6 minus 2 is just 4, so 4ac. So c squared minus 4ac minus 3a squared is equal to 0. No wait, plus 3a squared equals to 0. Okay, okay, that's fine. That gives me c equals to 3a or c equals to a, right? uh, but I assume that a, b, c are supposed to be distinct numbers. In that case c cannot be equal to a, so c equals to 3a will be our answer in that case. So c equals to 3a. Let's just find the value of b as well in terms of a and c. So c equals to 3a and b equals to a plus c upon 2, which is, let us see, so 4a upon 2, which is 2a. So a is to b is to c, that's the same thing as a is to 2a is to 3a, which is just 1 is to 2 is to 3. So that's the answer, 1 is to 2 is to 3. Okay, let's move on. Okay, so yeah, 1 is 2 is to 3, that should be our answer. The sum of an infinite GP is 57 and the sum of their cubes is 97 upon 9747. Okay, so 9747, fine. Then the common ratio of the GP is, so the sum of infinite GP is 57. Okay, fine. So that's like a upon 1 minus r is 57, and the sum of their cubes, which is a cubed upon 1 minus r cubed, that is 9747. Okay, cool. Then the common ratio of the GPU. So first of all, I'll just cube this equation. So a cubed upon 1 minus r complete cube, that has to be 57 cubed, and then I will divide it with this equation. So that will give me 1 minus r cubed upon 1 minus r complete cube. That has to be equal to 57 cubed upon 9747. Okay, cool. So now just want to find the ratio. Let us see. So looks like, okay, first of all just factor out this. So this will be like 1 minus r into 1 plus r squared, and then you got 1 minus r into 1 minus 2r plus r squared. Yeah, that looks correct. So this cancels. Okay, so it's supposed to be equal to 57 squared upon this thing. So is this a multiple of 57 as well? Let us see. So 57, that will, okay, so that's like 404 something, so 8 won't work. This does look like it's a factor of 57, so it's like 47 plus 5 something. uh yeah, let's just see if this is a factor of 57. So 9747 then divides by 57. So 1 minus 57, that has to be equal to 404. uh 8 won't work, so 7. So minus 35 and 49, 390 9 over there. So this is like 57 once again. So yes, it's a multiple, so it's 171 times that. Okay, cool. So it's 171 times 57, so this will be just 57 upon 171. Nice. In fact, 171, that's 3 times 57, so this is going to be 1 upon 3, I think. Okay, that's nice. So now we are in the position to solve this. First of all, I just want to cancel out some terms for this. From this I will write it as 1 plus, let us say, in fact I'll just do it in our usual method in that case. So 3 plus 3r plus 3r squared is equals to 1 minus 2r plus r squared. So that gives me 2r squared plus 5r plus 2 equals to 0. So that gives me what I can write as 4 plus 1. So 2r plus 1 into r, wait, what, why does this keep happening? R plus 2 equals to 0. Yes, that looks correct. So r can be negative half or negative 2, right? Yeah, that should be correct. Fine. So the common ratio of the GPs. But why does this not look correct? How can it be negative? That's what it is giving me, that it has to be negative. So 3 plus 3 plus 3 r squared equals to this guy. Yeah, it does seem like it's negative. So the ratio is in fact negative and none of these options are matching. Okay, so sum of the infinite GP is 57. Did we go wrong somewhere? Oh, it's supposed to be 57 cubed. Okay, so this is supposed to be 57 remaining over there. Oh, sorry for that. I actually squared that and that's why I got the incorrect answer. So it's supposed to be 57 upon 3. So this is a completely different equation in that case. Okay, fine. So that gives me 3 plus 3r plus 3r squared is equals to 57 minus 2 times of 57, which is 114r plus 57r squared. So that gives me, let us see, 57r squared. Okay, fine. And minus 117r. Yeah, correct. And plus, wait, not 57r squared, it's supposed to be 54 in that case. So 54r squared, I think. Plus 54 equals to 0. So is there some factor in this? 54 and 117, maybe 13 might work. This is getting much more complicated. So it's not a multiple of 2, so 2 into 25 into 27 is this. Okay, so these are in fact multiples of 9. So this is like 6r squared minus 1 and 3, so minus 13r plus 6 equals to 0. So 6 into 6 is just 36, which can also be written as 12 into 3, but that won't do. So it can also be written as let us see, maybe like 18 into something. No, okay, in fact yes, 18 into 2. No, that's not nice. So what now? How do we factorize this thing? That's 117. It does seem correct now. So how can I factorize this? 36 is 2 into 18, 3 into 12, then it can be 9 into 4. Well, that does work. So this can be written as 9 into 4. 6r squared minus 9r minus 4r plus 6 equals to 0. So that gives me 2r minus 3 into 3r minus 2 is equal to 0. So r can be 3 by 2 or 2 by 3. But because it's an infinite GP, I don't think r can be 3 by 2. So it has to be 2 by 3 in that case. Okay, cool. So yeah, it has to be 2 by 3. No problem. We'll just move on. So the maximum sum of the series 20 plus 19 and 1/3, then 18 and 2/3, and so on is. So the maximum sum of this series is, right, just what is happening over there? So 19 and 1/3, you got 2/3 out of that. Right, so every time you are subtracting 2/3 from this. So suppose you have n of these, right, n of these terms, then you have 20n minus n minus 1. Wait, no, not that thing. Okay, minus of n minus 1 terms, which okay, so minus of, let me just see, 0 plus 1 by 3. Wait, actually plus 2 by 3. Yes, plus 2 by 3, plus once again a 2 by 3, but 2 times of that thing, plus 3 times of a 2 by 3, and so on. Okay, so the maximum sum of this series is, basically what we just need to find is that when does this series start to decrease, in other words, when is the last term 0. So, and yes, this can be possible that the last term is 0. So you want 2 by 3 times x to be equal to 20, so that gives me x is equal to 30. So when you have 30 jumps or the 31st term, that will be 0. Okay, that's nice. So the maximum sum of that series, so we just want to look for n equals to 31 in that case, right? So we just want to find the sum of the first 31st numbers. Okay, cool. So how do we do that? It's going to be 31 upon 2 into 2a, which is 40, minus d, which is minus 2 by 3, plus nd, that has to be plus, no wait, actually minus all that. So minus 2/3 of 31, that has to be the sum, right? I think that's correct. So let's see what that's supposed to be. It's supposed to be 31 upon 2, and then you got something like that, right? In fact, you just do it like this. So minus 2 by 3 of 30. So this cancels, you got 1 over there, so like this is supposed to be 20 in that case. So 40 minus 20, it's just 20. So that's supposed to be 10, and then you got 310. So 310 is the maximum sum. Okay, the next question is, let a belong to 0 to 1 inclusive, satisfies the equation a power 2008 minus 2a plus 1 is equals to 0. Okay, and s equals to 1 plus a squared all the way till a power 2007, sum of all possible values of s is. So wow, this I was not expecting at all. Okay, cool. So you have s is equal to a power 2008 minus 1 upon a minus 1, right? So fine, and then we also know that a power 2008 is actually equal to 2a plus 1, 2a minus 1, sorry. So 2a minus 1 upon a minus 1, that has to be 2. So that's the only possible value in that case. Sum of all the possibilities of s is, this does look like that's the only possible value, and that is if a is not equal to 1. So what if a is equal to 1? If a is equal to 1, then also this equation is in fact satisfied, and then s will turn out to be 1 plus 1 plus 1. How many ones are there? 2008 ones. So s equals to 2 or s is equal to 2008. Therefore the sum of these values, that's supposed to be 2010 in that case. Fine. Okay, cool. Let's move on. So 2010, I think. Okay, if Tn is equals to 1 by 4 of n plus 2 into n plus 3 for n equals to 1, 2, 3 and so on, then 1 upon T1 plus 1 upon T2 plus 1 upon T3 all the way to 1 upon T2003 is, right? So 1 upon Tn, that is 4 upon n plus 2 into n plus 3, which is 4 upon n plus 2 minus 4 upon n plus 3, and this is for all n from 1 to 3. Okay, cool. Yeah, so let's see what this sum turns out to be. So first of all, you'll put 1 in there, so you get 4 upon 3 minus 4 upon 4. Then you put 2 in there, so you get 4 upon 4 minus 4 upon 5, then plus 4 upon 5 minus 4 upon 6, so on, till you eventually put 2003 over there. So 4 upon 2005 minus 4 upon 2006 over there. Okay, cool. So this cancels, everything cancels over there, and similarly this will also cancel. So we will be left with 4 by 3 minus 4 upon 2006. Okay, that will be our answer. Now just need to calculate that. So is 2006 a multiple of 3? No, it's not. Okay, so let's take for LCM next. do it like this. So 2006 minus 3, that's supposed to be 2003 over there, upon 3 times of that, this is like 6018. So that's supposed to be equal to 2003, 2 times of that upon 3009, right? Nice. Which is 4006 upon 3009. Okay, so that's nice. Where is that option? There is that option. So the next question is sum of the series 1 plus 4 by 5 plus 7 by 5 square plus 10 upon 5 cubed and so on till infinite terms is, right? So 4 upon 5, 7 upon 5 square. These are in fact in an AP on the numerator and the denominator is in a GP. So it's just a AGP. Okay, cool. So it's an Anatomical geometric series. So S equals to 1 plus 4 by 5 plus 7 by 5 squared and so on. So what will be 1 by 5S? That will be 1 by 5 plus 4 upon 5 squared plus 7 upon 5 cubed and so on. So if I subtract that, I will get 4 by 5S is equals to 1 plus 3 into 3 by 5 into something. So 3 by 5 plus 3 by 5 squared and so on. That's supposed to be 1 plus 3 by 5 upon 1 minus 1 by 5. So that's just 1 plus 3 by 4, which is 7 by 4. So our S will turn out to be 35 upon 16. So that should be correct. Let's see if there is some option like that. 35 upon 16. Yes, there is. So that's enough for one video. I will see you in the next one.